Alright, so let's look at another one with an oblique asymptote. So, looking at my domain, the first thing I'm going to do is factor. Oh my goodness, I have a sum of cubes, so I need to use SOMAS in the numerator. There we go. Denominator is a nice difference of squares. So that means my domain is negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. Remember, if you need a number line to do that correctly, go ahead. So since the degree of the numerator is greater than the denominator, I do not have a horizontal asymptote. So we'll see if I have an oblique. Since nothing is going to cancel, that means I am going to have an oblique. But since the denominator is not x minus k, basically the denominator is not linear, that means I'm going to have to use the box to divide. So x squared, 0x, negative 9. First term, first box. So that means I'm left with an x. Do your placeholder minus 9x. Now I have 0x squared. Oh, I want 0x squared. Cool. So that would be 0. What? Everything is 0. Guess what? All we care about, I don't care about my remainder. All I need is that equation, y equals x plus 0. That's my oblique asymptote. Well, that just simplifies to y equals x. So now we need to see if we cross the oblique asymptote or slant asymptote. So x, our oblique, equals our original function over x squared minus 9. Cross multiply x cubed minus 9x equals x cubed plus 8. Our x cubes cancel. Divide by negative 9. So we're going to cross at negative 9, 8 for my x value. Just going to write that over here. And then my y value I would plug in. Well, I have a really simple equation, right? Negative 9 over 8. My x values and my y values are equal everywhere. So now we're going to find our x-intercepts. That comes from setting my numerator equal to 0. Well, that first one, no big deal, negative 2, 0. Now here's a handy-dandy hint. If we did SOMAS, that means if we do quadratic formula on that quadratic, you're always going to get imaginary solutions. But if you can't remember that, you're just going to have to do the quadratic formula and take 5 years to do that to realize, oh, there's not anything going on with x-intercepts for that. Let's look at our y-intercept. So y-intercept, back in the original 0, 8 over negative 9. We didn't have any removables, so my vertical asymptotes come from denominator equal to 0, so x equals 3, x equals negative 3, not negative 9. There we go. We'll do our sign chart analysis over here. So what do we have? Yuck, yuck, yuck. Okay. This one, because I have so much going on, I'm actually going to just plug in some values to the numerator and plug in some values to the denominator for this one. But I'm still putting my normal critical values. So I'm putting my x-intercept of negative 2. I'm still putting my vertical asymptote of 3 and negative 3. But basically what I'm going to do is choose values like when we first did sign charts, just because I don't really want to plug in that quadratic up there. That's kind of gross. Okay, so I'm going to plug in negative 10 for here. Negative 10 cubed, that's a big negative, plus 8 is still going to be a big negative. Negative 10 squared is 100, minus 9 is positive, so that would give me a minus there. Okay, let's do negative 2.5. We don't have a lot of choices there. So negative 2.5, I actually might need our calculator. Gives me a negative here. And a negative here, so we're going to be a plus. Let's choose happy 0 for the next one, so positive, negative. Are these always going to alternate? You're really probably assuming they are, but they really aren't. Okay, 10, so positive, positive, positive. Alrighty. Once again, I'm choosing to do this because otherwise I need to put that big quadratic we did SOMAS on the top, and that just seems annoying. So we'll just plug it into two different things. So I have two vertical asymptotes, not vertical analysis. So I'm going to go ahead and do those. -3 from the left is going to negative infinity. That's a minus. Limit as we approach -3 from the right is positive infinity. As we approach 3 from the left is negative infinity. And as we approach 3 from the right, it goes to positive infinity. All right, so let's sketch some stuff. So I have my vertical asymptotes at -3, +3. We now have a slant asymptote at y equals x. Let's do this beautiful, beautiful line through here. Cool, cool. Now I have my x-intercept at -2, 0. We have a y-intercept at almost -1. And we're crossing our slant asymptote at -9/8, -9/8. All right, let's add in some arrows from my limit analysis. So from the left of 3, we're going down to negative infinity. To the right is above. To the left is down. To the right is above. All right, so we need to have, we're just going to sketch in our stuff now. So I know I need to be going down here, and we only have one spot where we're crossing. So that means the rest of that piece is just going to approach my slant asymptote. Now I know I need to be going up, and I'm just going to swoop through kind of like this. It's not cubic, but it's kind of cubic-y, right? Then I know that part's going to go up. We're not crossing anywhere else. So we're going to approach our slant asymptote.